lots of countries, they require a so-called stressing protocol. For that, you need to know the elongation of the stressing wire, which you kind of easily calculate out of the length of the wire, the stressing force, it's called E module, I would call it.
We call it hook.
Yeah, the
E module would be like, I would call it the hardness of the wire. So the harder it is, the less elongation you will expect. So what did we have? Length, the force, the E module, and of course the square of the stressing wire. Yes. So, and to do a protocol manually, you have to do an initial pull. You make a mark, you do final pull, and then you can measure the elongation from the initial to the final pull. Why do you do the initial pull? The initial pull is there that you have straightened up the wire. Before the initial pull, you have the wire like this inside your bed. You do the initial pull, the wire is straight, and from that point, you just measure elongation and not the straightening. That's why, and the reason for the measurement or for the stressing protocol with the elongation is a double check. So if something, you know, in the case that you have some technical malfunction on the machine with the elongation, you can see that. For example, 50 kilonewton would be equal to, theoretically, it depends on your line, but let's say it's equal to 20 centimeters of elongation, and you can just reach 15, there must be something wrong. You did not reach your required elongation, so something happened, whatever. It could be mechanically in the bed, it could be the machine, it could be 1,000 reasons, but at least you know something didn't go right. With that machine, you actually have the automated protocol writing system. So it's measuring the travel of the piston, which is basically in that little box here that you don't know from your regular stressing checks. And you measure the pressure directly in the stressing check, which is inside that little box. And from that pressure, the computer directly calculates into the force. And then you have a diagram which shows you straight force and elongation, and you can read probably what happened. So I would just do one pull on that cable, and you will see what happens on the screen.
So the elongation is measured by a measuring wheel?
Yes, in here, yes. It actually measures the travel distance of the
so it's
piston.
still the same old system from measuring wheel?
Yes. You probably already heard from the new system, which is not with a measuring wheel. It's we don't have one here because the prototype first one is actually at Boma.
Okay. I've used with the 2-hose jack, magnetic band, magnetic strip, and
that's what the new one actually, or how the new one works. All right. So you have loads of information on the screen. I will actually skip a lot of it right now. I will show you, actually I put it into English, that would probably help most of us. Right. So we have the worksheet. In the worksheet you have all the values that I just mentioned. So we have the required stressing force. We have the cross section of the wire, which is a 1/2 inch, which is equal to 93 square millimeters. We have the length of the wire, and it's always the length from lock to lock, because that's always the length that you stress. It's always from lock to lock. The maximum permission section is, that depends on the quality of your wire. The better the quality, the higher you can stress it. The E module that I just mentioned. And then we have 2 different points, which is initial stressing force or linear point. I prefer to work with a linear point that basically is just saying we start the measuring from 20% of the final force. What's the reason for that? The same reason I just mentioned before of the initial pull. We need to have some force to have the wire straightened. We just want to measure elongation. We don't want to measure straightening. That's why we do not start measuring at 0. And then we have some loss of the wedge seating. That's basically just if the wedge is being pulled by the force into the barrel, you will lose a little bit of the elongation again. So that will be automatically calculated as well over here.
Sorry, one question. And distance between internal wedges and cage wedges?
The shorter the bed, the more it counts.
How much?
Like
25 centimeters? No. Between cage and
It's
wedges.
actually you could actually add if you want, if you have an extended.
You can put it in
Yes, if you have an extended head, you can just add it here.
make it in minus.
Yes, if you have an extended head, that would be 15 centimeters extra.
Yeah.
All right. So after you've done all of that, as said before, I will not go into all the options that we have. We can actually go to the stressing, and over here we can have our protocol that will be made by the machine. You can have it, you can give it a name basically. So you can tell probably the component. You take the name of the customer. For example, I don't know, what's something international? You build a shop for IKEA, so it will be IKEA beam number 1, for example, or project IKEA beam number 1. So you always know the protocol which is for which project, which beam. And then you type in which anchor number you start. That's for, if for any reason you've been interrupted while the stressing process, you can start with anchor number 5 as well, but usually you start with 1 and you go through 1, 2, 3, 4 and so on. Alright, the worksheet, here we choose the worksheet, which is, this one is basically the one I was just showing you. We will be stressing with 50 kilonewtons now, which is moderate, so it should be quite fine. And then there's that point here. 50 kilonewtons would be equal to a pressure of 120 bars. So on here the machine is telling you how much to adjust for this stressing, for the wire stressing. One point, to be honest, you will actually be not able to have it 120.0. You will be somewhere 120.5, 0.6, 0.8. That doesn't matter. It's actually, it's not even 1%. So since this is a hydraulic system, you always have a little bit the pressure, never 100% straight. So I would just with the adjustment of the pressure, you just press the start, and I do not have a USB stick, and I already made that component, so I will just override it. I guess now I cannot. You just call it a different name because I already made that one. So if you have already a protocol with that name, you cannot put a second protocol with that name, of course, because that component is already done. So that was my testing yesterday, that's why it's already there. Alright, so we have a new name, anchor number 1, start, and if you would have a USB flash, I already confirmed it, it would be already writing your protocol onto the USB. If you don't have it, saving it internally, and you can put it onto the USB afterwards. Alright, and I would kindly ask you to not stand right directly behind it. Good. Now, while the stressing, you will see a red line. The linear point that I just mentioned at the worksheet is that green line here. That's actually the point where we'll start to measure. So the yellow line will be the perfect line, theoretical line. The white lines are our tolerance, and if you're in between the white lines with the red line, we're actually good. All right, let's see. You can see it starting up.
see this one changed to green, so we know this one was actually alright. So this is all within tolerance and good to use. You have this wire now saved internally on the computer because we didn't have a USB, we didn't have a flash drive to save it. But if you want to see it here, there you go. So you have your protocol, and here in Europe we have two different tolerances, which is the individual tolerance of every single wire, which is 10%, and we have the total tolerance, which is an average of all wires within one element, which is just 5%. So actually our individual tolerance for that one wire, we actually made it with the individual tolerance within 10%, but we didn't make it with the total tolerance, so we are actually more than 5% out. And that's what you will see here. That actually happened because those pipes are not 100% straight. We know that problem with our testing method. Okay, so that's basically how it works. Any questions? If you were working some time with it, you will be used to it, and it is actually quite helpful. It's a fast protocol. You don't have to do the initial pull, you go straight to the final pull because it starts measuring from a point that you define. It's not changeable afterwards, so it actually counts as a protocol. In Germany, for example, the German railway service, sometimes they want to have it. So on some projects they do not accept manual protocoling anymore. So you need to have a digital protocol, for example. But to be honest, the German railway service is not an easy customer. Yes. All right. If you have any questions, feel free to ask.